So hello students, today we are going to learn part 10 of trigonometry of class 10. Now in this part we are going to solve some examples on trigonometric identities. Okay, so before learning this or before solving this example, let us revise up till now what we have learned in this chapter. Okay, so we have learned about trigonometric ratios. Okay, now what are trigonometric ratios? So we have seen that these trigonometric ratios are possible in a right angle triangle. So we consider that triangle ABC is a right angle triangle, right angle at B, then the side opposite to this right angle is known as hypotenuse. This one is its height, this one is its base. Okay, now for this angle C, if we consider the value of angle C as an angle theta, okay, theta is its value, then for this theta, this side is opposite side and this side is its adjacent side. Now for this triangle, okay, we can write some trigonometric ratios, that are the six trigonometric ratios. Okay, sine, cos, tan, cot, sec and cosec. Okay, now we have seen these ratios, that sine theta is nothing but opposite upon hypotenuse, cos theta is nothing but adjacent upon hypotenuse, tan theta is opposite upon adjacent. Now if you look at this another identity, sorry, if you look at this other ratios, that is cot theta equals to adjacent upon opposite, sec theta is a hypotenuse upon adjacent, and cosec theta is a hypotenuse upon opposite. Okay, now there is some relation between these ratios, that is sine and cosec, cos and sec, tan and cot. Now what relation is there? If you look at the values, that sine theta is opposite upon hypotenuse and cosec theta is a hypotenuse upon opposite. That is, these ratios, they are, yes, reciprocal of each other. Okay, so we can directly say that from this we can say that sine theta is nothing but reciprocal of cosec theta and cosec theta is nothing but reciprocal of sine theta. Similarly, cos theta is 1 upon sec theta, therefore sec theta is 1 upon cos theta. Tan is reciprocal of cot, whereas cot is reciprocal of tan. We get two more ratios, that is tan theta can also be written as sine theta upon cos theta and cot theta can be written as cos theta upon sine theta. This ratios, this which we have seen now, we are going to use this one for solving examples of the next exercise. Okay, then after this we have learned about some trigonometric identities. Okay, near about three identities we have learned. We have seen in the previous period how we got these identities. Okay, our first identity is sine square theta plus cos square theta equals to 1. From this identity we derived more two identities or two ways it can be written. Second identity is 1 plus tan square theta equals to sec square theta and 1 plus cot square theta equals to cosec square theta. Okay, then we have seen next part, that is complementary angles. Okay, sine theta can be written as complementary of cos, that is sine theta equals to cos 90 minus theta. Similarly, cos theta equals to sine 90 minus theta. Tan, it can be written as cot 90 minus theta. Sec, it can be written as cosec 90 minus theta. Okay, now in the next exercise we are going to deal with this all formulas, okay, which you can see in front of you. We are going to deal with these ratios also, then the relation of these ratios with each other, trigonometric identities, then complementary angles also. Okay, these all things we are going to use in the next exercise. Okay, so now let us solve some examples based on this exercise. Now exercise 8.4, first example is given as evaluate, means we have to find the value of sine square 63 plus a sine square 27. Now remember that this 63 and 27 are any angle. Okay, upon cos square 17 plus cos square 73. Okay, now if you want to solve this one, none of the angles seems to be similar to each other. Okay, so what we will do, we have learned one ratio, that is trigonometric complementary angles. Okay, so sine theta can be written as cos 90 minus theta. So we will do one thing, this sine 27, let us write this one as cos 90 minus 27. Okay, so in next step what you get, okay, now we have written its complement over here. Okay, so you will get sine square 63 plus complement of this one, that is cos square 90 minus 27. Similarly here also we have done the same thing. Okay, we have written complement of this cos square 73, so we get cos square 17 plus sine square 90 minus 73. Okay, now this value sine square cos square, it doesn't affect, but we can make changes in this one. Now 90 minus 27, so it will become again 63, and 90 minus 73, it will become 17. Now if you look at this ratio, it is similar to an identity. We can write it as sine square theta plus cos square theta. Why theta? Because these both angles are same, divided by cos square theta plus sine square theta. Okay, now we have an identity. Let us check it. Do we have an identity for sine square theta plus cos square theta? So yes, we have sine square theta plus cos square theta equals to 1. So this value we are going to use over here. Okay, so instead of this one, it is nothing but sine square theta plus cos square theta. So instead of this, what we will write there? 1, and denominator also same. Cos square theta plus sine square theta means same as above. So what you will get, this one also as 1. So what is our final answer? 1. Okay. So what we have done, we have used here two things. First, we have used here complementary angles, and here we have used, yes, which rule? We have used trigonometric identities. Okay. So accordingly, we should solve it. Okay. Now let us solve one more example. It is good if you are able to learn all the formulas, then it will be easy for you to understand the example and solve that example. Now let us consider same example, example based on similar concept. Now here we have sine 25 into cos 65 plus cos 25 into sine 65. Now again same condition. Now here these two angles are equal, these two are same. Let us do one thing. Amongst any one of this one, let us take complementary of angle. Okay, but remember that here if you take complementary of 25, so here also you have to take complement of 25 only. Okay, so let us check it. So now what we have, now this sine 25 we have written as it is. So here cos 65 is given, so we have written its complement as sine 90 minus 65. Then plus sign was there, then this cos 25 we kept as it is. As I told earlier, if here you are making change in this angle, here also you have to make change in the same angle. Okay, cos 25 plus, now this sine 65 can be written as cos 90 minus 65. So we have written, yes, what we have written, complement of these two angles. Okay, now in next step, so what you will get now, this sine 25 as it is. Now this sine 90 minus 65 will become sine 25 again. This cos 25 as it is, and this cos 90 minus 65 will become as it is. Okay, now here it is not plus, it is into. Okay, now it can be seen that what do we have, sine 25 into sine 25. Okay, so sine into sine will become sine square. Similarly, this cos 25 into cos 25, it will become cos square. Okay, so what you get in next step now, now we get this one as sine square 25. Remember, we cannot find a square of this angle. Okay, it will be as it is, only these ratios will multiply with each other. Okay, now here we have cos 25 into cos 25, so it will become cos square 25. Now again same ratios, or we can say that same value is there for that angle, so we can consider this one to be as sine square theta plus cos square theta. Now we have seen what is the value of sine square theta plus cos square theta, so it is nothing but 1. Okay, so what is our final answer? 1. So just to go through these all formulas. Okay, whatever formulas we have written, you do practice, make a triangle in this way, write all the ratios, then a relation of that ratios with each other, then write the trigonometric identities, and complementary angles. If you're doing this much practice, then we can easily solve our next exercise. Okay, so this much is enough for today. Thank you. Have a nice day.